Hello everyone, welcome to Lecture 3, Module 1. Recent developments in electronics materials. Spintronics. The development of electrons has spread in many specialized branches such as bioelectronics, molecular electronics, spintronics, rubber electronics, polymer electronics, nanoelectronics, etc. Now, among these, the spin electronics is one of the fast emerging field. So, when we look at the word spintronics, it is spin electronics. It relates to spin dependent phenomena which are manipulated to achieve a desired electronic outcome, such as a quantum computing. Now, in order to brief what exactly is spin electronics, we have seen that the electron is going to revolve around the nucleus. Apart from that, the electron also rotate on its own momentum. So by electron rotating on its own momentum and around the nucleus, it is going to create an magnetic field. So when the electron rotate either in clockwise or anti-clockwise, there will be a small amount of magnetic field created. Now, when the electron rotates in clockwise, it creates a magnetic force and that is directed downward. And if the electron charge always, if rotates in counterclockwise, it creates a magnetic field in upward directions. So the electron charge always creates a magnetic field whenever it is rotating either in clockwise or anti-clockwise. If it is stationary, it will not create any magnetic field. So this is how the picturization has been given here. So when the electron rotates in clockwise direction, the magnetic field is created in a downward position. And if the electron is rotated in anti-clockwise direction, the magnetic field is created in upward direction. So it is going to create a magnetic field making a north and south pole. Right. So here you can see this. Spin can contribute a small magnet into electronics, into magnetic field, and in case of all electronics equipment. So what we have seen is that spintronics is contributing to a large amount of electronics, and in case of hard disk, making memories. So spintronics is the study of the role that is played by the spin of electron in solid state physics and other devices. Spintronic is also known as spin flectrotronics, and it is the study of intrinsic spin of the electron, and it is associated with the magnetic moment. That is what is spintronics. For example, spin transport and spin relaxation in semiconductor and metals are important for the solid state physics issues that are included in the fundamental research along with the new technology being implemented in the electronic storage technology. Now the future work in spintronics. Creation of spin polarization through optical and magnetic injection, spin polarized transport through semiconductor, spin relaxation in metals and semiconductor, spin based devices such as PN junction and amplifier, spin based quantum computation and electro entanglement in different semiconductor devices. There are several kinds of spintronics devices which are in the stage of development and in concept. They may be a bipolar device such as spin diodes, spin transistor, spin polarized solar cells, magnetic diodes, etc. These devices are attractive for the purpose of magnetic sensor and memory storage application, such as hard disk, such as pen drive, such as your memory cards. Now, what are the major fields of spintronic research? Research on spintronic concentrates on the development of advanced material. The ferromagnetic semiconductor are the most used materials which combines the characteristic of ferromagnetism and semiconductor both. The major researches are the development of spin-based devices such as PN junction and amplifier, relaxation behavior in metals and semiconductors, spin polarized transportation through the semiconductor and the semiconductor interfaces. Fourth one, spin based quantum computation. And the fifth one is quantum computer hardware. So these are the major fields of spintronic researches. Now we need to look at the working principle of spintronic devices. Now on the application of magnetic field in normal metals, there is a change in the resistance. This is normally of the order of 1% of the magnetic field of Tesla. Now in some of the ferromagnetic metals, the direction of magnetization can be reversed when a magnetic field of the order 0.001 Tesla is applied. This results in a phenomena called magnetoresistance, which is utilized in commercial production of small magnetic reed heads. They can sense a very small magnetic fields in written information on the hard disk. This causes the considerable decrease in the space required for storing the bit of information. Thus, the storage capacity of the hard disk increases. So the spintronic is going to carry some information. It is going to transmit the information from the head to the slave part, so that the slave can read the data from the particular hard disk. Now, what are the emerging and futuristic spintronic materials? The utility of semiconductor spintronic devices depends on the availability of suitable materials which retain ferromagnetic property above a room temperature. Now, some recent and important materials in the list are following: half metallic materials such as Fe2O4, ferric oxide, colossal magnetoresistive materials such as SR doped, half helicellular alloy having composition of XYZ, and ferromagnetic semiconductor. Now we'll be looking at ferromagnetic semiconductor. As I said, spintronic is a combination of ferromagnetism as well as a combination of a semiconductor. So spintronic is based on the spin of electrons rather than the charge. So electron is going to exist in two states, namely spin up and spin down. Right. In other words, the electron can rotate either in clockwise or anti-clockwise around its own axis. So this type of spin is going to create a tiny magnetic field. So the two possible states are the zeros and 1. So this bit of information is called qubit. So basically the spin of the electron makes a tiny magnet with north and south pole. So the ferromagnetic materials such as iron, nickel are necessary for designing of spin electronic devices. Right. Now, ferromagnetic semiconductor. Here, the magnetic semiconductors are semiconductor materials which exhibits both ferromagnetism and some useful semiconductor property. Right. So, in case of magnetic bipolar diode, which is called as MBD, here the P region is of magnetic semiconductor, that is gallium manganese arsenide, or you can say the gallium arsenide is doped with manganese, and the N region is conventional semiconductor compound which is having a compound of gallium arsenide. So here the P type and the N type are the silent application of ferromagnetic semiconductor. Now similarly, when we look at a biomagnetic bipolar transistor, which is of a great use. Now it consists of conventional semiconductor, emitter, collector and a base of p-type magnetic semiconductor. Now we'll be looking at the element of such materials presenting existing memory device such as SRAM, that is semiconductor random access memory, and dynamic random access memory, that is DRAM, can be combined to produce an MRAM, that is magnetic random access memory, which combines the advantage of high speed access and high density. Now RAM, so random access memory, has become a generic term for the semiconductor memory that can be only written and as well as read. It is a volatile memory which loses its data when the power is turned off. However, it is very fast and less expensive than the non-volatile memory such as your hard disk. Now, this type of memory is used for the main memory in most of the computers. Now, the DRAM, here the DRAM is the dynamic random access memory, which consists of one capacitor and one transistor to store each bit and forms a memory cell. It is a type of random access semiconductor memory. So the presently existing memory are the SRAM and the DRAM. Now these two RAMs, when are combined, they are forming a magnetic RAM, which is having advantage of high speed access, high density information storage and non-volatility. So as we know, RAM is very important part of the CPU. So it is, if you use magnetic RAM, it is of high speed, you have high density of data can be stored, and it's a non-volatile memory. So in order to be ferromagnetic at room temperature, they are required to have Curie temperature above the room temperature. So we'll be studying about this ferromagnetic material and what exactly is Curie temperature in module 3. So this is what has been explained. Now the emerging wide band gaps. So the emerging materials having wide band gap semiconductor that retains its ferromagnetic property above room temperature are given below. Now the first one is the indium manganese arsenide. It is a metal insulator semiconductor which is suitable for working at low temperature. It may be used as a magnetic sensors. Gallium manganese arsenide, or you can say gallium arsenide compounded with manganese. It is suitable for high spin injection. It is used for infrared, LED and lasers. Next is zinc germanium diphosphide. So here the material exhibits unusual nonlinear optical properties. It can be used in optical oscillations. The last one is the zinc arsenide compounded with tin. It shows the promise for frequency converters and infrared generations. So these are the various wide band gap or the upcoming futuristic materials which are used in spintronics. Thank you.